jobs. Let's first take a look at the Chiha cluster. How many of you guys are familiar with on-demand? I know I can't see you guys, but I'm just going to give a brief. Yeah, I'm just going to give a brief intro of on-demand, and then we can actually go ahead and start looking at the Slum scheduler. So uh, Chiha is an HPC system, and on-demand is the web interface for the Chiha system that basically makes it a bit more simpler for people to access the cluster, utilize the functionalities, and it just makes the experience consistent across different OSs as well. So if somebody is working on Windows, if somebody is working on Mac, somebody is working on Linux, all of those people are going to have a similar experience of working with HPC cluster since it's running on a web browser, and Google Chrome is, I think it is available for all three OSs, and Firefox is available for all three OSs. So basically, to come to on demand, you just go to rc.uab.edu and you are going to get on this dashboard. And this is going to be the dashboard that you're going to see. It has some information. We put some notices up there, as and when things are happening, we put these notices and take them out. We have uh, some remote resources for our office hours and things over here at this link. So this notice keeps changing depending upon the day and what kind of notice we want to send out to people. You can check your files over here. The first time when you get an account, you get 3 spaces on Chiha by default. One is your home directory, that is only 20 gigs of space. So 20 gigs is not a lot of space for your raw data. If you're working with raw data, you'll know that some of the files can be more than 20 gigs of size. Home directory is just there to either keep just the scripts, not raw data, the scripts that are going to be working on that raw data, you can keep that there. Or generally, like how we try to do it is we just basically avoid home altogether. We just go to data user location and we keep our scripts over there, we keep our raw data over there. The reason we avoid home directory is that a lot of softwares utilize home directory for their purpose. So if you're using Anaconda, if you're using RStudio, MATLAB, and a bunch of other softwares, they utilize that space on the home directory uh, to run the software properly. So if at any point you run out of the space that you have in your home directory, you are going to start seeing weird errors with your software.
Yep,
Yeah.
absolutely. So I like to think of it as home directory is kind of like your wallet. You really can't fit a lot of things in there, but the stuff that's there is really important. And then data user is kind of like your closet. You can fit a lot more things in there. And data scratch is kind of like your locker at the rec center. You can put stuff in there. It will stay for a while, but if you leave it there for a long period of time, the janitor will clear it out at some point. So that's kind of my mental framework for it.
Yeah, that's a good example. Lockers in rec center. Um, so this is basically what's the locations that you get on Chiha, storage locations that you get on Chiha. We are going to avoid this jobs for now. It's a job composer and active jobs, or actually we might come back to job composer later. Active jobs is the jobs that are running for you on the cluster right now. If you go to this link, and job composer is okay, I don't have any job running right now, so it doesn't show anything. uh, and job composer is on demand's method of submitting slum jobs directly on the cluster. But initially we are going to begin with some uh, basic methods of starting jobs on Chiha. All right, so let's go to clusters. Under clusters, you're going to see Chiha shell access. And once you click on that, you're going to come to a command line interface. Some of the things that you'll notice, this is the same screen that you see on the dashboard of on demand. Uh, and One of the other things that you're going to notice is your Blazor ID at the rate this login 001 node. And, and you're also going to see the home directory. So, uh, like I mentioned, we generally don't try to keep too many things in the home directory. So as soon as you get here, you can change directory with cd data user of 89. Also, one of the other things that you need to take care of is that you're not running anything very computationally heavy on the login nodes. Login node is kind of a space where you land. If and The only thing that you are supposed to do over here is either start an interactive job or submit a batch job. uh, if your job takes more than 10 seconds to run, or if the computational thing that you're trying to do takes more than 10 seconds to run, or requires more than 2 or 3 gigs, it's I think it's more appropriate that we ask for an interactive job. Once we get that resource allocation, we go over there and then run our computational job over there.
Yep. Yeah. So just to underscore that point, um, if you're doing anything other than just navigating around, make sure that you don't see this login 001, that you see like C00 something, because this is the login node that everybody shares to log into the cluster and work. So if you start doing things on this login node, it would be similar to if somebody else had a keyboard and mouse for your computer, and when you're starting to do an analysis, that they came and started up a whole bunch of programs, watching movies and playing StarCraft or whatever on your machine. It's going to make it really hard to do anything. And so if you're not just navigating around, make sure that you start up a compute session.
Yeah, and so the method of getting to a compute node is pretty simple. So on Chiha, we use Slurm scheduler. So scheduler is like an entity that takes requests from you. So you request for, I want a resource for 2 hours, I want 2 gigs of RAM, and basically I want it on this node, I want a GPU or not. You give these kind of resources. Slurm scheduler, the entity, it goes and tries to find that resource for you amongst our, I think it's 160 something nodes that we have right now, and all those 160 nodes have multiple CPUs, 24 or 28 CPUs. So it goes across all of them and it tries to find the resource request that resource that you requested. It tries to find that slot in all those nodes. And once it finds those nodes, it's going to assign you those nodes depending on the availability. And So the way you request those resources from Slum is, if you just search for Chiha Slum on Google, this is the first link that you should come to. And we are going to begin with interactive jobs. Once you land on this page, it's docs.ubcrit.ub.edu/wiki/slum. And once you land on this one, go to interactive jobs. And I want to run something, but I don't really need GPU. So I don't need to really run this part, but I can just copy paste this and run this. So in this request, what you're asking for, you're running srun, that's a Slurm executable. You're telling Slurm that it's a job that's only going to have one tasks. It's We want 4 CPUs per task. So in total, since we asked for one task and 4 CPUs per task, this job is going to have 4 CPUs assigned to it. And now we also want 4096. The value that you give over here, it's in megabytes. So this is 4 gigs. And we want 4 gigs per CPU. So in total, we are asking for 16 gigs of RAM because we asked for 4 CPUs. So, and time, we are asking for 8 hours. Partition is sort of dependent on how much time you are asking it for. Uh, like if you take a look over here, you're going to see the maximum runtime allocated for each partition. So since I was asking for 8 hours, I could have chosen short, which I should have done actually. Uh, we need to update that example because the
Yep.
the smallest partition that you ask for that corresponds to the maximum runtime that's available, you will have a higher priority. So Slurm is basically a fair share scheduler. That what that means is it has a lot of criteria based on which it assigns your jobs a point.
Mhm.
And one of those things is like short has a higher priority than medium partition. And if if I wasn't supposed to exceed 12 hours, if I wasn't asking for 13 hours, using short will give me a higher priority than me using medium with the same 8 hours.
Yeah.
And there are a bunch of other factors as well, like how many jobs you ran um, in the past, how many jobs you have currently running, because we also limit how much a person can request from the total resources available on Chiha. Like William was mentioning at the beginning that he is at the limit of his quota of how many CPUs or RAM he can use at one point. So uh, he wouldn't be able to ask for resources right now
Yep.
since his jobs are already running. And this is basically done so that everyone can come and utilize Chiha appropriately.
Yep. Yeah. No. Absolutely. And so, yep. That point about the partition, you can always run shorter than your partition. So like here, you can use 8 hours, even though you're requesting a medium partition, which allows you to go up to 50 hours. But Slurm uses those names, express, short, medium, long, to decide how long it thinks you're going to need that for. And so it, it's important to try to match that as close as you can to the time that you're actually going to use, because if you use 8 hours and you're in a medium partition, then you're going to have to wait longer than if you just ask for a short partition for that same amount of time.
Yeah, and so you'll see that once the job got started, you'll see that rather than having a login 001 over here, I'm not sure why my Siri is starting all the time. But rather than login 001, you are going to see some C00 number or C0 some number. When you see that, that basically means that you are in a Slurm job right now. So feel free to run your computationally intensive tasks right now. Even if your computationally intensive tasks exceed the RAM that you have asked for, it might exceed this 8-hour limit. You are free to run those things over here because now your job is constricted by these values. So if you exceed 16 gigs of RAM over here in your job, it's going to cancel out and it's going to give you errors that the memory requested uh, uh, was not sufficient for the job that you ran. So you can, next time you run this, you can ask for more resources. You can ask for about 5 gigs over here, so in total 20 gigs for your job. Or you can ask for more time if you had a timeout error at the end. uh, but eventually, I mean, so the first time you are trying to create your workflows, there is sort of a hit and miss kind of mentality where you try to gather the resources. Suppose you had asked for these resources and your job ran successfully, but ultimately your job was just using 2 gigs rather than 16 gigs that you have requested. All those things you can uh, take into account or check using S account and try to adjust your resource request according to that. Are there any questions about interactive job?
Not seeing anything pop up so far.
So if I just ask, I see one from Clem.
Oh, yeah. can I run packages on this interactive job? So yes, Clem, this would be the appropriate place to run packages like Python, um, or R or MATLAB, what have you, would be inside of a compute job. Now, depending on what package that you're using, you could run that inside of the interactive sessions from Open On Demand. What is a muscle aligner? Is that a Python package? Is it a standalone program? Yeah, so most likely um, you're going to want to run, if it's for aligning a lot of data, you're probably going to want to run it inside of a batch job. You certainly could run it inside of an interactive job, and that would be the appropriate place to start exploring the use of that program. But once you figure out the parameters that you like to run it on and how many resources you need to actually run it, um, running it on a batch job, which I think is coming up next, will be more useful to you in the long run.
All right. And one of the messages that I received was if I can just ask for 16 in the CPU, is that good enough? Is that equivalent to this? Yeah, I mean, depending upon the thing that you are trying to run, if your software that you're trying to use can utilize multi-threading, then it might be more useful to have multiple CPUs and some RAM allocated to all those CPUs. But if your software that you're trying to use does not utilize multi-threading, then you can just ask for one CPU per task and define 16 gigs over here. Or you can just define dash dash mem. Dash dash mem gives you that in this node, you are only going to get whatever memory that you asked for. So 16 gigs in that case.
Yeah, and that's a good point. You know, this is endlessly configurable. You can go one way or the other. Just asking for more RAM isn't necessarily going to make your process faster. And similarly, just asking for more CPUs won't necessarily make your process go faster unless it's configured to take advantage of those additional resources. So a lot of times in these tutorials, you'll see Ravi and me ask for 4 CPUs and 4 gigs of RAM per CPU, because that's roughly equivalent to a nice computational laptop. So we've got the MacBooks that have the 4 CPUs, or the quad core CPUs. So that's 4 CPUs and 16 gigs of RAM. And so if you ask for that, you'll see similar performance on Chiha to what you would see on like a desktop or laptop computer that's pretty decent for doing computational stuff. So it's a good place to start.
All right. And so this resource request that we had, it was just for normal CPUs. We didn't want GPUs in this case. But supposedly, if you want to use GPUs, you can come over here and you can take a look at this. It's almost exactly similar to this, apart from two parameters that change. First of all, the partition changes to Pascal nodes. And so if you want a GPU, you have to use this partition. And the other thing that gets added is this dash dash crest equal to GPUs to 1. That tells us how many GPUs we want. Each of our GPU nodes has 4 GPUs, and so this with this request, you define how many GPUs do you actually want. It again depends on the software that you're using. Asking for 4 CPUs would not make your workflow run any faster if your workflow is not actually utilizing 4 GPUs. But if it is, feel free to ask for 4 GPUs. You can also if you are using some of the libraries, because it's not very common, we generally tend to avoid that topic, but just so that you guys are aware, if you are using some of the libraries that allows you to combine GPUs from two or three different nodes, I forget the name of that library from Uber.
Horovode.
Yeah, Horovod. So if you're using some library like Horovod or something that allows you to use GPUs from multiple nodes, then feel free to ask for more number of nodes. So you can ask for, I think you can specify dash n equal to 1, that's going to or dash n equal to 2, that's going to give you two of these nodes, and both of them are going to have four GPUs that are assigned to yours. So in total you can have 8 GPUs in total. Just keep in mind that utilization of Horovod and all those things are not very trivial. So there is a very high chance that the software that you are running might not be utilizing all the resources. In that case, just plan to stick to one of the nodes.
Yep.
And you'll also see this S interactive. The S interactive is useful when you have some of the applications that you're trying to run, if they have a GUI component, that's where S interactive comes into play. On demand has taken some of the use cases of S interactive, because now you can just come to S interactive, start up an interactive session, and just choose HPC desktop, and and specify these parameters, how many hours do you want it for, partition, CPUs, memory per CPU. And once you land in that job, I don't know how long it's going to take for this to start, but once this starts, you are already in a job, so you can run things over there directly. But initially, we had to use S Interactive. Even now, if you are using VNC, S Interactive is the tool that you might want to use if you have some application that has a GUI component or graphical user interface component.
Yep. Yep. So I think next, if nobody has any more questions about the interactive jobs, we're going to start moving on to looking at the batch jobs and array jobs and job dependencies if we have time to get there.
Yeah, and so let's just go with an example batch job script. You can again find this in Slum, in the Slum wiki page. This is just an example job script. It doesn't do much. It just prints the host name and it prints the sleep 60, or it sleeps for 60 seconds just to show that the job is running. That's the only reason why this thing is there. If you take a look at this command and some of the parameters that you pass, you'll see that there are a lot of similarities, because there are really a lot of similarities. These are exactly copied over here. So you see dash dash CPUs per task and dash dash CPUs per task. One of the differences in the batch job script is you have three components generally in a batch job script. First of all, you have this header hash bin bash that should be available in all the Slum batch jobs that you submit. Then you have this hash sbatch directives. These tell these tell the Slum scheduler to interpret these lines wherever it starts with hash sbatch in a different manner than how generally most of the tools generally interpret hash as a commented outline. Like, if I specify this is a commented outline. Slum is not going to do anything with it. But if I specify hash sbatch, that has a special meaning for Slum that tells that over here you are asking for resources, or you are setting metadata for your job scripts. So if I have hash sbatch, this job name has some special meaning to Slum. And similarly, you can just add these different parameters. You can have job name, you can have output and error files. These are going to be standard output and standard error files. What that basically means is, when I ran these were the this is the standard output. So if I do an ls, This is the standard output. And all this standard output is going to get saved in result.out. And if I had any errors in my tasks that I'm trying to run, they are going to get saved in result.error. That's standard error. Sorry. And we have already talked about most of these other things. So one other new thing over here would be you can specify mail type and mail user. So mail user is pretty simple. You add your email address over here. So, and in mail type you specify when Slum should send you an email to this address. So I've specified fail. So only if the Slum job fails should Slum send me an email. But you can specify all over here as well. So it's going to send you an email at every stage. That basically means that once you submit the bad job, it's going to send you an email. When it moves from pending to starting state, it's going to send you an email. If it's when it fails, it's going to send you an email. If when it ends, it's going to send you an email. When it changes to completing state, it's going to send you an email. And that can be, I don't know, exhausting. I don't want so many emails in my I don't want so many emails for just one job, especially considering that if when you reach the stage of running batch jobs, that generally means that you are trying to scale up your operations. That means you are running thousands of these job scripts at the same time, basically. So you created your workflow using interactive jobs, and then once you move to this, you are trying to implement that same workflow, but rather than on one input, you are trying to implement it on thousands of inputs. And if you're getting so many emails from one job, getting all those emails again from thousands of jobs, that's going to be overwhelming. So
Yeah.
generally keep it at fail or end. You can add with a comma, you can add end as well, so that you know when the job is ending. But for me, generally I prefer fail. I think that's the
Yeah. And
best reason when some Slum should send me an email.
yeah, well, and even so, if you scale this up, when we talk about array jobs, you'll see how you can submit a lot of jobs at once. Um, even once you move to having multiple, lots of jobs, even the fail emails can get overwhelming if you're still kind of working out your workflow. So I have a folder, like an email rule in my email client to go ahead and move all of the Slurm emails into a folder, because I really don't need to see them unless I want to go back and look at the email specifically. So I don't delete them because I asked for them, but I do put them automatically in a folder. So that's also a useful thing to do.
Yeah. To run this job, let's see. All right. Think, yeah, I see that. All right. I'm just going to make a temp directory. I hope everyone is able to see my screen.
Yeah, I think we can see it.
All right. Let's create a test.job, a test example dot job. I'm going to create this file, and I'm just doing nothing over here. I'm just copying pasting. One thing that I can change is my email address. But other than that, I don't need to really change much over here. So method of submitting a batch job is simple enough. It's just s batch and the name of the script. So test example.job. The method of checking if your job is running is sq-u and your Blazor ID. And you'll see that mine is pending right now. uh, because of priority. It didn't have a lot of resources that I was requesting, so I'm expecting it to start soon. But you can see that there are two jobs that are already running. That's one is the OOD VNC that I showed. So this one. And one is the reason why I'm over here on a compute node. This job. Yeah, this one. So those two jobs are running. This one is in pending state right now. Hopefully it's, yeah. So now you'll see that it's in a running state. It has been running for 18 seconds. Remember, we slept for 16 seconds in this job. So this is going to run for 61 seconds or about 1 minute. And I think it adds things at the end. Yeah, well, it has already added. So this basically tells the first command that we were running was host name, and it has printed out the host name, that is C0030. So that's where this job was running. And now it's just going to sleep, and eventually it's going to go out of this SQ.
So Lisa, so Lisa asks, how do I modify the example job script to include my personal shell script? And so what you would do is, rather than, so if Ravi, if you can open up the job script.
Yeah, I can, let me create the test bash.sh.
Okay, yep.
And I'm going to just add a few things that I want to run over here. So /bin/bash, and I want to run date command, and I want to run ls command, I guess.
Yep.
I'm going to make it an executable because I need that to run. Otherwise, I won't be able to run it from here either. Or I can, but I generally prefer this method. That basically means, so if I run ./test, it gives me a date and it gives me this ls. Now what I can do is I can go to test, yeah, example dot job.
Yep. And then you can replace one of those lines with the name of your executable.
Yeah,
And you don't have to have, and I've seen some instances where having srun in front of my command causes a failure. So you don't have to have srun in front of the command, but you can. That for more advanced use, that gives you some fine-grained control over what resources are used for each piece.
yeah. Especially when
But
you're setting your environment, I think modules doesn't like an srun in front of it for sure.
yeah, and so by just specifying your script here to just say, okay, run my script, it's going to run that script on the resources you requested whenever they get scheduled.
All right, so sbatch test example.job. Oh, it might take a second, but it's going to give you almost the same output as this one.
Yep, just be a different time.
Yeah. All right, we'll keep that. Whenever it starts running, we can come back and take a look.
Yeah, and yeah, to answer that question, so Lisa also asks, will it create the error and output files? So the uh, in the example script there on the Slurm page, we specify the error and output files. If you specify a specific name, so like in this instance, we specified res.err and res.out, it will overwrite that file each time it runs this job. If you don't specify either name, it will create a output file that has both the error and the standard out in it, called slurm dash whatever the job number is, dot something. I can't remember what the dot out or something like that. I can't remember what the file extension is. So I personally avoid setting the output and error because if you don't set those, it will automatically create a unique file for this job script every time it runs.
Mm-hmm.
The other way that you can do that is by using the job number as part of the argument for the output or the error. And that way you can have job names that make sense as part of your output and error file names, which is helpful, and have it continue to be unique so you don't overwrite your output files.
Yep. All right. So for now, we have seen a batch job that's running on its own. So the next thing that we are going to take a look at is array jobs. So if you have been using Chiha for a while, and if you have worked on a big project, you would have noticed that there are multiple inputs that you can see. So it's generally like you have 100 test subjects. So you have test 1, test 2, test 3, test 4, test 5 to test 100, and you want to run the same workflow on all of them. But so there are several methods how you can go about it. You can either manually create those job scripts on your own for each different one. You can utilize bash scripting to create so you can use bash scripting that's going to help you create all those job scripts, and then you submit them there. So the first manual process has a lot of manual work, and it's really time consuming. Bash scripting is good that you don't have to do the manual work, but Slurm, once you start submitting those jobs, what happens is Slurm scheduler gets overloaded if you start submitting hundreds or thousands of jobs at the same time, and then it's just going to start acting up. So either you submit them in batches of 40 jobs or 20 or 30 jobs, uh, or you can use what uh, a built-in method from in Slurm that's called array jobs. And we have examples over here. Basically, there is. Do we have this link posted in chat, William?
Yes. Yeah, we do.
Okay. And so basically, in array jobs, you have different methods. So if you have sequential file names on which you are trying to work, you can utilize this method. Or if you have random file names, which is also possible. I mean, I know everyone tries to keep their input data set and all the data set that they generally have in a very organized manner, but more often than not you will come across where rather than your files being named test 1, test 2, test 3, test 4, they are named as Ravi, William, Ishan, Louis, and some individual names. So we know that they are people's name. For computer they are random. So this is where you can utilize random file names. In random file names we create array, a bash array, and then utilize that with this lum array task ID that generally goes from 0, 1, 2, 3, depending upon which array job is running. And I think it's much more useful if I show it in the form of over here. All right, I think this should have run. Yeah, all right, it's done. So let's convert this into an array job. All right. All right. Hash dispatch dash dash array equal to 1. Is it dash 10 or is colon 10?
It's dash. Yeah.
Okay. And so what we are going to do over here is we are not trying to create any workflow or anything. What we are basically going to do is we are going to create files that are going to be named based on these. So let's comment out these things, or actually let's just delete them. And I don't know if you guys are familiar with touch command. Touch, basically what it does is Uh, touch is basically it just creates the file even if there is no input. Otherwise, most of the editors that or command line editors that you're going to use, if the file is empty, they do not save that file. With touch, you can have a file. I'm going to just show you an example after this. All right, test dollars. I want to copy, write this. All right. So once we run this, our hope is that there are going to be 10 files in this folder called test1, test2, test3, test4 till test10. And there were different methods how you could do it. Either you can create a batch job script for these ones, so that where you can have touch test1, then you create another job script where you have test2, test3, and so on. But rather than that, we are just going to use this array functionality and this variable that gets defined. All right. So it's just to show you an example was touch commands too. So let's take a look at what files are over here. All right. I'm going to create res1. So touch res1 dot sh, and you'll see that res1 dot sh is there and it's empty. It doesn't have any value. But it's still printed out this. Otherwise, if I was trying to do a vim and I don't add anything and I do an ls, actually it has started creating vim too. All right. Looks like vim has added this functionality too, but we are using touch because we will have to close vim inside the job script as well.
Yeah.
All right. Sbatch test example.job. All right. Now you'll see that these are the job IDs that have been submitted, 1 to 10.
And this is really cool. So this is an important thing to note. So you notice that when it's submitted, we only see one line. It just says 1 to 10, but then as soon as the job starts running, it splits it up into 10 different jobs. And so from a scheduling standpoint, if I ran a script to submit each job separately, it would show up as 10 jobs in the queue and then 10 jobs when it starts running. So you can actually overwhelm the scheduler by submitting 1,000 jobs at one time. But if you use the array job, the scheduler basically sees that you're asking for 10 jobs, but it has a card that says I need 10 jobs rather than 10 cards, one for each job. And
Yeah.
so it's a subtle difference, but it really helps the scheduler a lot. And then on the flip side, you can actually specify a parameter to only run a few of your jobs at one time. And so you don't have to put as many as your allocation will allow.
Yeah, and if you'll take a look, it has created all these files that we wanted by just running one array job. I know we haven't gotten too much into detail about bash array jobs. Feel free to read up on this GitLab repo
Yep.
with
And
bash.
feel free to come to our office hours. The link for that Zoom is on the on-demand message at the top.
Yeah, and hopefully this should be self-explanatory. We do have a decent README for this uh, bash array jobs, and we have all the scripts available over here. But yeah, definitely reach out to us if you guys have any issues.
Yeah.
And job dependencies. All right, we might. I think we have time for at least one
Yeah.
small example.
Yeah, we can at least talk through it, even if we don't run it. So each one of these jobs, again, they're not doing anything. They're just sleeping for a couple of minutes. So we probably won't run it because we don't have time for them to all run so that we can see how they follow through. Um, uh, but basically, these take advantage of a wrapper here, this job submission wrapper, and then this SBR at the bottom is a wrapper around the SBatch command. And so you just keep that SBR script inside of the same folder, and this will output the job number as a result, so that then you can set up your job dependencies in the job script. So if you go to the job submission script, so the SBR will put the job ID that's generated from the SBatch command in this variable, this JID0 or JID1. And so what'll happen is you'll get your job ID from job 0, and then you can use that with this command dash dash dependency equals after any to say, after any of these jobs, particularly job ID 0, that's when you can run job1.sbatch, and then
Yeah,
so forth and so on.
yeah. To show a small example. Let's see if we can show a small example for this. We basically just need to sleep for 120 seconds just to show that, and we don't need this array.
Mm-hmm.
All right, and I'm going to copy this file again so that we can sample2.job. Oh, sorry. All right, so what basically is happening is we are submitting test example dot job, but our second job, test example 2.job, is dependent on this job to complete, and then only we want to start this job. That's our ultimate goal, right, with this dependency method.
Yeah.
And so we submit this, and we
Yeah.
get the job ID,
And
and
then go SBatch. Yeah, that's
all
right.
right,
Yep. So
s
SBatch, just example 2. Yep. Yeah, that's right.
all right, and now if I take a look, so at least the first one has started,
Yeah.
and the second one is pending because of a dependency. It has a dependency on this. This one would not start till this job has finished. Still
Yes.
dependency. I should have set it to 60 seconds.
Yeah.
2 minutes is a long wait.
It is. It is. So yeah. So feel free to play around with the scripts, the array job scripts and the job submission scripts. I think the other thing we've got in the array job scripts is some array jobs that take in inputs from text files, which can be really useful in setting your parameters if you have like a spreadsheet that has different parameters um, per instance. So with that, we're kind of running up against the end of our time. Let's see if we've got other questions. All right, so Clem asks, if we run packages in an interactive job, even if they are heavy computation, are we going to mess anyone else up? I'm going to do a batch job, but I was just checking. So yes, that's the beauty of the job system, is that if you're running packages in an interactive job, it should not mess anybody else up. If it does, that's an error in the scheduler or some of the other boundaries that we have on the cluster, and that's a bug that we need to fix on our end. That's not your fault. And so if you're doing heavy computation, you're probably asking for a lot of resources. So that's where the batch jobs really come in handy, is you may have to wait for a while if you ask for a lot of resources in an interactive job. Whereas if you submit a batch job, it'll run whenever the resources come available, and you don't necessarily have to be sitting there waiting for it. And then Lisa asks, what's the link for the Zoom office hours? So Lisa, if you go to rc.uab.edu, yeah, right here, like Ravi has it shown. If you go to this go.uab.edu/research computing remote, that's up at the top, it will it'll provide the links for the 3 instances of office hours that we have.
All
Any
right,
other?
so yeah, over here, the once the dependency job finished, it had clearance to start, and for the first 2 3, it was waiting for the priority, and then it just started running,
Yeah,
just to show that job dependency.
yeah, perfect, perfect. And so the job dependency is a nice way of setting up a larger, more complicated workflow where you have to process some data and then do another process to it, and then do another process after that, without putting it in a single monster script, which is always nice to avoid. With that, if nobody else has any questions, I'm going to end oh, we've got something here. I've never used any of this, and I have no idea where the R code will go and how to download packages. All right, so that's a really good question. So the R packages will go into your personal space, and so you don't have to worry about them overlapping with somebody else's stuff. I would say, Ruba, that I would recommend that you come to the office hours, and so that we can help you more specifically on your questions about how to get started with R. Um, the YouTube session and then Lisa's asking about the YouTube session. This is available right this very minute. I would say that as soon as I click the end of the stream, it will probably take maybe 5 minutes or so to show up on the YouTube channel. So I'm going to go ahead and click stop live stream now.